Hey, how's everyone doing today? So in this video, we're gonna do a few things. The first thing we're gonna do is to review the definition of an isosceles triangle. Then we're gonna look at some important terminology. We're gonna define the isosceles triangle theorem, which I also like to refer to as the base angles theorem, and then we're actually going to prove this theorem. So let's get started. First things first. Definition of an isosceles triangle. An isosceles triangle is a triangle with at least two congruent sides. Okay, so again, an isosceles triangle is a triangle with at least two congruent sides. Now, again, there's some very specific terminology when we talk about the parts of an isosceles triangle, and we're going to go over that right now. So if you look here, we can tell that this diagram is or represents an isosceles triangle because we have two sides that are labeled congruent. So these two congruent sides are called legs of the isosceles triangle. This angle up at the top is called the vertex angle. Down here, this segment is called the base. And then finally, these remaining two angles that are opposite of the congruent sides or opposite of the legs are called the base angles. Again, so this is all important terminology, and we're going to be using this quite frequently when we're talking about isosceles triangles. So the isosceles triangle theorem, which I don't know if I said this earlier, but it's a very important theorem and it's very useful. Okay, reads that if two sides of a triangle are congruent, then the angles opposite these sides are also congruent. So again, if we take a look back at the original diagram, all right, we have our legs that are congruent. So the base angles that are opposite those legs are going to be congruent. Okay, and that's why sometimes I would call this the base angles theorem. Okay, so we've again gone through and reviewed the definition of an isosceles triangle. We've talked about important terminology, and we've also defined the base angles theorem or the isosceles triangle theorem. What we're going to do now is actually go through and do a proof of the base angles theorem. So let me erase this board. And we're going to slide this up and prove the base angles theorem. So let's go ahead and do that. So here we're given that triangle RPS is an isosceles triangle, and that PQ bisects angle SPR, and we want to prove that angle R is congruent to angle S. So let's kind of plan this out. Now, really what we're trying to do here, or what we're going to try and do, is to use CP-CTC, so corresponding parts of congruent triangles are congruent, to help us prove that angle R and angle S are congruent. So what I want to do here is prove that triangle RPQ is congruent to triangle SPQ, and then again say that R and S are congruent by CP-CTC. So let's get started on that. First off, let's write down the given information. Triangle RPS is isosceles, and PQ bisects angle SPR. And that is given information. So let's go ahead and mark our diagram appropriately here based off of what our given information tells us. So RPS is isosceles, which means that two of the sides are going to be congruent. So in this case, I'm going to say that RP is congruent to PS. All right, that's by the definition of an isosceles triangle. And what we also know is that PQ bisects angle SPR. So that means angle 1 and angle 2 are going to be congruent. So really, in order to prove that RPQ is congruent to SPQ, all we need is one more congruent statement. And in this case, it's just going to be this side right here would be congruent to itself to give us side angle side. So let's go ahead and actually complete this proof. So first things first, RPS is isosceles, and we said that RP is congruent to SP, and that's by the definition of an isosceles triangle. We also said that angle 1 and angle 2 are congruent. And that's the definition of an angle bisector. Now again, from the onset we said that we wanted to prove that we had two congruent triangles and use CP/CTC to prove that the base angles are congruent. So here, if we say that segment PQ is congruent to itself by the reflexive property, now we know that triangle RPQ has to be congruent to triangle SPQ, and that's by side angle side. So RPQ, let's erase that. Triangle RPQ congruent to triangle SPQ because of side angle side. And now the base angles that we're trying to prove congruent, angle R, angle S, have to be congruent because of CP/CTC, or the definition of congruent triangles. So angle R congruent to angle S because of CP/CTC. All right, so that's a quick proof of the base angles theorem, or the isosceles triangle theorem. What we're going to do in the next video is we're going to look at some corollaries, some very useful corollaries to this theorem, and then we'll look at some examples of how this can be used to solve problems. I hope this video was helpful, and we'll see you in the next one.